That last clip ran on a little. I thought I'd stopped the recording and I hadn't. So there were about 20 seconds of dead space. I had to go ahead and finish that particular recording to see what had happened. Okay, so anyhow, we see that we do the integration of the u prime function, and we add that to the u naught. So let's look at the integration of the u prime function. The u prime function is very straightforward. Negative 1/5 t e to the negative t. You can verify that the solution, the integral of t e to the negative t, is negative t e to the negative t minus e to the negative t. Taking that times negative 1/5, we get these terms. The integral of 1/5 with respect to t is t. Remember, we're integrating from 0 to t, so that our antiderivative of the t e to the negative t function needs to be also evaluated at 0, and we need to subtract that result, which means that we're going to end up subtracting 1/5, because when t equals 0, this antiderivative does equal 1/5. It gets a little messier with the 2/5 and the 3/5 and the e to the negative 6t and the e to the negative 5t, but the integrals are straightforward, and I believe I have the constants right here. I believe that the integral of 2/5 t e to the negative 6t is negative t over 15 times t e to the negative 6t minus e to the negative 6t over 90 of all things. And the integral of 3/5, or the antiderivative of 3/5 e to the negative 5t, 3/25 t e to the negative 5. Oh, darn. There is a mistake there. Let me fix it. Okay, let me just show you what I did. That I'm going to have to go off camera and just kind of rewrite all of this. I integrated 3/5 t e to the negative 5t instead of just 3/5 e to the negative 5t, so that all of this stuff here is wrong. This should have just been, what, negative 3/25 e to the 5t. So that should have been negative 3/25 e to the negative 5t. And this fraction is not going to be as bad as it was. It's still not going to be great. But all this kind of goes away and has to be replaced, and then the constants that I get down here are going to be modified. So I'm going to have to rewrite these matrices and go off camera, and when I come back, these things will have been replaced. Okay, this is still, it's not quite as bad as it was. At least we can do the fractions in our head. Doing the integrations, we end up with what we have here. Again, I integrated 3/5 t e to the negative 5t, causing myself a little more trouble than I needed. Common denominator here is pretty clearly 450. So putting all these fractions over denominator 450 and noting, oh no, these are still wrong. Let me fix it. Okay, maybe I have it right now. The mistake I had here, I had 89 instead of 59. If we plug t equals 0 into these antiderivatives, because these are just, this is the antiderivative of what we have here, I get a 0 here. Here I get negative 1/90th. Here I get negative 3/25. 1/90th is 5/450th. 25 goes into 450 18 times, which is fairly easy to see. 3 times 18 is 54. So we have a negative 54 450ths and a 5 450ths, which is a negative 59 450ths. And of course we subtract the, well, I don't have the integral up here. The 0 represents the lower limit on integration, so we'd be subtracting that, which means we'll have the plus 59 over 450. These constants might be right. You can double check this. in any case. Then I add a 0 here and a 1 here. Why do I add a 0 here and a 1 here? It's because u0 is the vector 0, 1. So I'm going to add 0, I'm going to add 1. 59, 450 is plus 1. 1 is 450 over 450. 450 and 59 is 509. We get this. And this may or may not be correct, but I think it's certainly the right form, and I think maybe it is correct. So this is our u of t vector. Are we done yet? No. What was our solution, our assumption? Our assumption was that the solution would be 5t times u of t. So we're going to have to multiply this u of t vector that we've obtained here by this matrix to get a y1, y2, and that y1 and that y2 will be particular solutions of the original problem. Now I'm going to write down the solution. I'm going to do that off camera. So multiplying our psi matrix by our u matrix. Psi matrix here. U matrix is y1, y2. Well, sorry, no, U matrix is this matrix. Y1, Y2 is the product matrix. We can write it out here. It's written a little small because it's really spread out. Here's our psi matrix. Here's our U matrix. Our U matrix is just this matrix. So that when we multiply through negative 3e to the t multiplied by the first row, e to the 6t multiplied by the second row, that negative 3e to the t multiplied by 1/5 t plus 1 e to the negative t, e to the t and e to the negative t just give us 1. So we get negative 3/5 times t plus 1, which is what we write here. Then negative 3e to the t times 1/5 t is negative 3/5 t e to the t. Not written very well there. We can see a t e to the t down here. And it turns out that these solutions, well, we'll see in a minute. Okay, and then negative 3e to the t times negative 1/5 is 3/5 e to the t. Multiplying by e to the 6t, and multiplying the second component of our u vector by the e to the negative 6t, by e to the 6t, we see that we get rid of the e to the negative 6t here, leaving us the negative 1/90th times 6t plus 1. The e to the negative 5t times e to the 6t is going to be e to the t, and we're still going to have the coefficient negative 3 over 25. And the 509 over 450 will just be multiplied by the e to the 6t. Without reading it all to you, doing the same thing in the second row, we have a multiple of e to the t as we did before, which is multiplied by the first row, giving us terms of the same type, just with slightly different coefficients because of the different coefficient here. And the coefficient here, the e to the 6t again, is the same as this, so that all these terms over here, which came from multiplying the second row by the second component of the u vector, are going to be the same for both rows. So we end up with this solution to our equation, and that's our y vector, or our y1, y2 component functions. Were we to write these functions out, take their derivatives, plug them in here, and that would be a little bit of a tedious exercise, but just a matter of bookkeeping. Then if I've done my bookkeeping throughout this solution, we should get identities. And without writing it out, I'll just point out why it's plausible, at least, that I maybe do have the right solution. Follow me for a second. 3y1 is going to give us negative 9/5 t. 3y2 is going to give us 6/5 t. So that's negative 3/5 t. Over here, we're going to have 3 times 6/90, which is 6/90 times 3 is 18/90, which is 1/5. Going to have a negative 1/5 from this, 1/5 t, a negative 1/5 t from here. So we have negative 3/5, a negative 1/5, and negative 1/5, which is negative t. So that 3y1 plus 3y2 is going to give us a negative t, which added to this t gives us 0. Why should that give us 0? Because the derivative of this function here has no t terms in it. So the derivative of our y1 function has a 0 coefficient on t. None of these terms can give you a constant multiple of t. So at least with that one brief check, there's a plausibility that maybe I got the solution correct. Why don't you check out the rest of the solution and let me know?